All right, let's talk about quality management. Now, quality management is a knowledge area that focuses on delivering the product or service or result to a particular standard that meets the customer's requirements. And quality is very important because it ensures that the needs of the customer is met. If the if the product's quality is not good enough, then it means the customer can reject the product that we're trying to create. And this is why quality is an important knowledge area. Now, in the quality knowledge area, we just have three processes, which means it's one of the shortest knowledge areas in terms of processes. There are just three things you need to know. The first process is where we have the plant quality management, and this is where we create the quality management plan. And within the quality management plan, we have the um, we have the quality objectives that we want to achieve, right? Maybe quality objectives could be the defect rate or how many products can be defective within maybe less than 2% should be defective if at all we are going to have any defects. The quality objectives, we can also have the um, quality standards. What quality standards do we want to meet in a project? It has to be determined. Quality standards for the materials, quality standards for the way work is done. Then the quality management plan will include goals and responsibilities. This talks about people that are going to be responsible for taking quality activities. And then another thing, the another output of plant quality is the quality metrics. And the quality metrics determine what is tested. So let's say that one of your products, to determine the quality of that product, we have to weigh it. It means that one of your quality metrics is weight, and you must test the weight of each item to determine whether quality is achieved or not. So that's what happens in the first process of plant quality. In the second process, which is known as managed quality, this is this is also where quality assurance is done, and this is also where uh, process improvement, process improvement, and product design for X, they are done here, right? So in managed quality, the highlight of that process is quality assurance. In other words, it's a managed quality, quality assurance is done. And then the final process focuses on quality control. So we have quality assurance and we have quality control. And the question is, what's the difference between them? So as we go into the course, we're going to look at the difference between quality assurance and quality control, right? The difference between quality assurance and quality control. So these are the three processes in quality. The first process falls under planning, the planning process group. That means creating a quality management plan, determine the objectives and standards are actually part of planning. That means we determine the standards in advance, the quality objectives and so on is done in planning. Managed quality is actually done while we're executing a project, and that's when quality assurance is done. And in quality control or control quality is where we do the final product testing to see whether it passes or not. So these are three major processes in quality management, and this is the pathway to um, to understanding how quality management works. So there are just three basic processes: plan quality, come up with your quality standards, manage quality. Manage quality is more or less talking about ensuring that manage quality is performing quality assurance, which means carrying out the processes as they are meant to be, and quality control is where we test the final product against specification. So let's move on. Let's move on. So let's talk about quality. Let's define quality. Now, quality is a word we use a lot, but let's put a definition to that word. Quality is the degree to which a set of inherent characteristics fulfill requirements. Quality is the closeness, how close you came into meeting the requirements of the customer. That's quality. The degree to which a set of inner characteristics meets up with a requirement is the definition of quality. The degree to which a set of inner characteristics meets up with requirements. Now, let me give an example of this so that we can get more understanding. So, quality, right, is the degree to which a set of inner characteristics. Now, let's look at this class. For you to join this class, your computer or your phone or your tab must have a set of inner characteristics that enables them, enables the tab or phone or laptop to join the class. So when we say the set of inner characteristics, we're talking about things that have been built into the product or service that enables the product or service to meet the requirements. So take, for example, for you to join a Zoom call, a YouTube page, there are some things that have been worked into your computer that enables your computer to meet up with the requirements of using this application. Right. So that is what we mean by a set of inner characteristics. There are things that have been built into the product or service and enables the product or service to meet certain requirements. For a laptop, these inner characteristics could be your hard disk drive, your RAM, your processor speed, and other things that makes the computer to function and meet up with the requirements of using a Zoom application or even visiting the YouTube website. So that is what we are saying. Now, the goal of quality processes is to align them with the International Organization for Standardization. And this means that we are also looking at that processes can be standardized. ISO is a global body that is into quality and standardization. So it is to ensure that our processes align with global standards, ISO standards as well. They should generally align with concepts created by Deming, Durand, and Crosby. Such concept example is total quality management, Six Sigma, failure mode and effect analysis, voice of the customer, continuous improvement, and cost of quality. So we're going to talk about some of these topics in our journey into quality. Some of the ones we're going to talk about first include the Deming cycle and how Deming cycle has improved quality. So let's talk about total quality management. Now, total quality management is a philosophy that was created by Dr. Deming, who happened to be a PhD holder in electrical engineering. Now, total quality management is what a lot of companies use to ensure that they are running on quality systems. The total quality management was created by Dr. Deming. Now, the truth of this is that Dr. Deming was sent to Japan after the Second World War to help the Japanese rebuild their economy. Right. So in the workshops he had, Dr. Deming actually tutored Toyota. And of course, if you can ring the bell, you see that Toyota is the family that owns the Toyota Corporation, right? So total quality management was actually influenced by Dr. Deming and his work. And that's what brought total quality management. And one of the people that actually learned from Dr. Deming is Toyota. And this is one of the reasons why Toyota is the best place to get case studies on quality, right? So the total quality management consists on a proactive attitude towards quality with a detail towards statistical analysis to document improvement. So for total quality management to work, we have to take data and look at how to improve the quality of a system or product over time, relying on data and statistical analysis. Now, Dr. Deming became a celebrity in Japan. And the reason I'm saying that is because the Deming price for quality, the Deming price of quality, Deming price of quality was actually issued in Japan. Now, Dr. Deming is an American, and the Japanese were celebrating his achievements, accomplishments. So, if you want to do anything notable in Japan as a quality expert, you have to, get the Deming Prize of Quality. And so, Dr. Deming was a celebrity in Japan because of this introduction to quality management. Right. So something happened in the late 80s. In the late 80s, there was an oil crisis, and there was shortage of crude oil. Now, the downside for the average American is that Americans love big trucks and, big cars rather than trucks, big cars that have a big engine. Of course, the number of American cars still today that they are large in engine size. But the problem is when there was a oil, oil crisis, right, and the cost of crude oil had gone up, right. The Japanese who had mastered fuel efficient cars now started selling and almost taking over business from American cars, Ford and Ford and General Motors. So what happened was that Dr. Deming was not happy with the development because, after all, he had helped the Chinese people to improve their quality. Now they are now taking business away from his fellow Americans. And at this time, Dr. Deming had gone back to the US after completing his assignment in Japan. So he wrote a book called Out of Crisis. That book was dedicated to Americans on how they can outcompete the Japanese, right? Out of Crisis. So that book, Out of Crisis, later became the 14 Principles of Management, right? 14 Principles of Management, which were viewed as a basis for total quality management, was founded, right? So it is a book that actually created total quality management. The following are the basic principles: be proactive, not reactive, use leadership and accountability, measure and strive for constant improvement. Measure and strive for constant improvement. So the following are the basic principles: be proactive, not reactive, use leadership and accountability, measure and strive for constant improvement. So total quality management became a quality management system, which was drawn out of the book Out of Crisis that Dr. Deming created for American businesses to be able to compete with Japanese businesses. And so Dr. Deming also left us with something called the Deming cycle for quality improvement. And this is what it looks like. So for quality to improve over time, we have quality improving over time. We have the quality improvement. We have the Deming cycle, and it's a cycle that looks like this, and it actually is a cycle that is divided into 4 quadrants. Okay, and that is plan to check act, PDCA cycle. So this is what we refer to as the Deming cycle, PDCA cycle, plan to check act cycle. And Deming cycle is used for quality improvement, and it leads to, it's also a continuous improvement cycle. Now, what does PDCA mean? Plan, do, check, act. So P stands for plan, and P is where we look at problems that we need to solve. We start with plan. Plan means with we come up with solutions that can solve the problem. So that's plan. Then do is to implement each solution, right? And test which solution is the best. Check is where we check the results, and act is where we implement the best solution. So you could call it a problem-solving approach. You could call it a quality improvement approach, where we look for issues, defects, problems, come up with possible solutions, implement those solutions, check for the best solution, and act on it. That means deploy it. That is the plan to check act cycle, Deming cycle. So total quality management is used by organization as a quality management system to help improve processes within an organization by taking data of those processes and looking for ways to improve them. Let's talk about another quality philosophy called zero defect. Zero defect is a philosophy created by Philip Crosby, and the basic foundation is that if we do something, if we want to do anything, we should do it right the first time, right? So that we don't have to repeat it. The basic foundation is to do something right initially, and you shouldn't have to repeat it. As with most quality initiatives, if the money is spent upfront, the effort will eliminate the need for rework if the defects occur. So, in terms of zero defect, we are talking about planning upfront to ensure that things are done right the first time and we don't have to rework. Now, for zero defect to work, it means everybody has to take ownership of quality. Let me explain how zero defect can work. So let's say that people are working in the factory and they're assembling a car. If everybody takes ownership of the quality of their work, it means that the person installing the steering wheel will check that the steering wheels are well installed. It means that the person installing the brakes will check that the brakes are well installed. If everybody takes ownership of their work and checks that the quality of their work is good, when we assemble the car, we should expect zero defect because everybody has checked their work and the sum total of our work will lead to zero defect. So this was created by Philip Crosby. It's a philosophy that if we take time to plan our work and ensure it is done well, we will not need to rework or repair anything if we have planned to do the work well the first time. Now, fitness for use is another concept that was created by Joseph Brown. And fitness for use means that the needs of the customer and stakeholders are defined and then we attempt to satisfy. So for fitness for use, we want to understand the real needs of the customer. For fitness for use, we want to understand what the customer really needs and try to attempt to satisfy. Now, how does fitness for use work? It works by getting customer feedback. So if I create a product and I give it to my customers, I'm waiting for their feedback to see how to ensure that it meets their needs. That's what we call fitness for use. And fitness for use relies on what we call the voice of the customer. The voice of the customer. And voice of the customer simply means customer feedback. Have you ever been in a bank where you saw rather, you saw suggestion box? Suggestion box is an opportunity for you to suggest how the bank can improve their services. You know, in some banks, you still see them, although it's kind of like an old concept, but you still see them in some banks. There's this box where you see suggestion box. That's actually voice of the customer because you can, recommend things that the bank or a business should do to improve its services. So we have what we call the voice of the customer. Then we have continuous improvement. So when we talk about continuous improvement, we're talking about Kaizen, continuous improvement. Now, Kaizen was made popular by Toyota in terms of being able to constantly improve processes over time, right? And Kaizen is actually a Japanese culture of continuous improvement. According to the Japanese culture, if you see your neighbor, maybe you haven't seen your neighbor in 2 days, the moment you set eyes on your neighbor, you have to start looking at how your neighbor has gone to improve themselves. So if you haven't seen your neighbor in 2 days, the expectation is that they've gone to improve themselves in 2 days and you now start inspecting. So Kaizen is a mindset of continuous improvement, which means we always look for opportunities to improve our processes over time, right? So Kaizen is continuous improvement, and it's a culture of always looking for ways to make things better. So, and this is why a country like Japan experiences deflation and not inflation. Inflation is where the economy, things get more and more expensive. Deflation is where things are getting cheaper and the value of money is getting better because improvement is ongoing, which means if we are experiencing a deflation, it means that you have money in the bank and you're getting richer because the economy is getting better. And that is Kaizen, looking for ways to continuously improve everything you do. It's a culture, right? It's something that is culturally part of the way we work in terms of continuous improvement. And we're going to see how continuous improvement is implemented in this knowledge area as well. Now, what is gold plating? Gold plating is the practice of giving the customer more than what they requested. Is the practice of providing more than what the customer requested for. According to PMI, this practice is unacceptable and professionally irresponsible. It is unacceptable and professionally irresponsible. The project manager and team should provide only that which was approved. So gold plating is the practice of providing more than what the customer requested, and that is what we refer to as gold plating. Now, why is it not accepted? If you give your customer more than what they requested for, they should be happy, shouldn't they? Yes, they should be happy, but it is wrong according to PMI. That's what we're saying. You know, in customer service, there's this saying that you under promise and over deliver. In project management, we don't do that. We give the customer exactly what we promised them because that will be called gold plating when you give the customer more than what they requested for. The question is, why is this bad? Now, gold plating is bad in project management. Please note the focus is on project management. Gold plating is bad because it's exceeding the customer's requirements. Now, let's look at the definition of quality. We said quality is the degree to which a set of inherent characteristics meets up with requirements. Is the degree to which we meet requirements. It is not the degree to which we exceed requirements. Providing more than what the customer requested for is exceeding the customer's requirements, and that is going outside quality. So gold plating is when we do things that were not requested, and even though the customer likes it, according to project management PMI, it is wrong. We do not gold plate. We do not surprise our customer. We don't tell the customer, hey, come and see what I've done to your house. And then you go and show them a surprise. No, we don't do that in project management. What we can do, which is allowed, is if you think the customer will benefit more based on your experience as a project manager with similar projects, you tell them that it's possible that they can get more value if they include this in their project. If the customer accepts and now requests it, it's no longer gold plating because they requested it. But not that we use our own experience and say, oh, this is what the customer must like, and you do it. And even if they like it, doesn't make it right as a project manager. You've just done something not professional. It's unprofessional to gold plate. Now let's talk about the very first process in quality, and that is called plan quality management. And plan quality management is where the quality standards for the project and deliverables are identified. the quality standards for the project are identified, and it will also show how the project will meet the quality needs of the project, right? And this is where we come up with a quality plan on how we're going to meet up with the standards of the product or deliverables and the project itself. Let's look at the process for creating the quality management plan. And of course, there are a lot of input tools and techniques to look at. So we'll just look at some of them. In order to create the quality management plan, we can look at the project charter, and the project charter has high-level requirements for the project. Then, of course, the requirements management plan, which shows how requirements will be collected, managed, documented, and prioritized. So the requirements management plan governs how requirements are collected and managed throughout the project. The risk management plan shows how risks are going to be managed in the project. And stakeholder engagement plan shows how we're going to engage stakeholders in order to ensure that their quality needs are met. Stakeholder engagement could come in the form of having workshops or interviews with stakeholders to actually understand their needs. Then the scope baseline includes the scope statement, work breakdown structure, and the work breakdown structure dictionary. The scope statement includes the acceptance criteria, which also talks to the expected things that the project must meet, the acceptance criteria. The assumptions log is also an input. This is where the assumptions and constraints are listed in the project. The requirements documentation is the document that shows all the requirements of the project. We also have the requirements traceability matrix, which helps us to track requirements and ensure that all of them are met. We have the risk, and in the risk register, we can look at risks that can impact on quality, right here. And we also look at stakeholders who are impacted, who can be impacted based on the quality of the project and which part of the project lifecycle they are interested in terms of quality. Now, enterprise environmental factors refer to things like government standards. When it comes to quality, government standards are very important because based on government standards, you can draw your quality requirements. And then organization process assets. This looks at the organization's internal quality standards and quality policies. Now, expert judgment. So when we talk about expert judgment, we have several techniques. Number one, to come up with the quality standards of a project, you can benchmark by comparing to another project that was done, maybe according to best practices, and we draw our quality standards from that other project. Or experts can brainstorm to determine the quality standards of the current project. Or we can have interview sessions with quality experts or subject matter experts to determine the quality standards. Now, when we look at data analysis, we can talk about cost benefit analysis. And this is where we justify the cost of, the benefit rather. Let me talk about benefit, the benefit that quality will bring us. Now, there are 5 major benefits of quality, but it's not an exclusive list. So if you're creating a cost benefit analysis, you may want to invest in quality for any of these 5 reasons. 1, increase in quality leads to increase in profitability. Now, What do we mean? What do I mean by increase in quality leads to increase in profitability? Now, do you notice that every year iPhone releases a new model? This year is last year it was iPhone. Okay, this year was iPhone 17 Pro Max. Next year we're expecting iPhone 18 Pro Max if things don't change. Now, but do you know that a new iPhone also means a slightly higher margin, a slightly higher profit, which means the price goes up a little bit more. And that means each time they improve the quality, they're also increasing the price. So increase in quality leads to increase in profitability. And so we can almost guess that iPhone 18 Pro Max will be slightly more expensive than iPhone 17 Pro Max. So increase in quality leads to increase in profitability. Increase in quality leads to increase in productivity. Now, a higher quality product normally can do more than a lower quality product. This is why iPhone 17 Pro Max has some features that iPhone 16 Pro Max doesn't. It has to be more productive, and that's another benefit. Increase in quality leads to less operating costs. Less operating costs. One of the less operating costs, right? Less operating costs. One of the signs of good quality products is that they actually cost you less to operate, less operating cost. Now, let's talk about cars. One of the reasons why in a country like Nigeria, people love Toyota cars is because they have lower operating cost. It's actually lower, not less, lower operating cost. If you own a Toyota car, you are guaranteed of fuel efficiency, you're guaranteed of low maintenance costs, and that's a sign of high quality products. So that's a benefit. Another benefit of quality is less rework. If you buy a high quality product, let's again talk about cars. Yeah, one sign of a good quality car is how often do you go to the mechanic? Less rework. Rework is repair work. So if it's a poor quality car or maybe a low brand, there's this Chinese brand called Lifan, Lifan. If you buy Lifan, a friend of mine in university bought a Lifan. That's the first time I would see the car, Chinese car. And when he bought the car, people were praising him, a big boy on campus. After 2 weeks, it was as if the car started sucking his blood because the car was always at the mechanics. He kept on repairing and repairing. This week, if it's not break, it will be something in the engine or tire or something. So one of the signs of high quality products is less rework, less repair work. And lastly, another benefit of quality is increase in quality leads to increase in customer satisfaction, which is probably the most important, probably. Now, these are 5 benefits of quality, and we can make a justification for quality from any of them. So when we talk about cost benefit analysis, this is where we see the benefit that quality brings instead of its cost. Because the truth be said, quality is going to cost you. It's going to cost you something, but we don't focus on the cost, we focus on the benefit quality brings. Then we have cost of quality. Now, cost of quality is where we look at the cost of conformance to quality versus the cost of non-conformance to quality. Cost of conformance to quality versus cost of non-conformance to quality. That is the cost of quality, right? So, um, so when we talk about cost of conformance versus cost of non-conformance, we are looking at which one we should go for. Now, let me explain cost of conformance. Cost of conformance is the money you spend to attain a particular quality standard, right? And cost of non-conformance is the money you spend because you didn't pay attention to the cost of conformance. So when we look at cost of quality, we are either leaning on cost of conformance, where we are proactively improving quality, or being reactive in cost of non-conformance. Let me give a simple example. Now, someone is building a house, and that person wants a good quality house. Part of his cost of conformance would be to do a soil test, especially if it's in a particular area. So doing a soil test is part of your cost of conformance to ensure that the right foundation is used to build a house. Now, if someone ignores the cost of conformance and ignores it, which means they want to build a house, but they're not ready to do any soil test. No, don't worry, just use any foundation. What is going to happen if the wrong foundation is used is the cost of non-conformance. Because they did not pay attention to the cost of conformance by doing a soil test, they're now going to pay for cost of non-conformance, because if the foundation is wrong, the house might begin to sink or tilt to one side, and the cost of non-conformance will be the money you spend to repair that defect. So when we look at cost of quality, it has two sides. You either pay for the cost of conformance or pay for the cost of non-conformance. It is always better to pay for the cost of conformance. Then we also look at decision making, multi-criteria decision analysis. In determining the quality standards of your project, you have to look at several factors like cost, like value, like several factors to determine quality standards. Take, for example, someone wants to build a five-star hotel, and he wants that every hotel room has a jacuzzi. Now, that's a good way of setting your hotel apart. But what are the other factors that you must consider if that's the standard you want? Having a jacuzzi in each hotel room means that you have to consider power cost. You have to consider the effect of the water supply on the building, because it means that people are going to use a lot of water, the power, the energy consumption. These are other factors that can influence determining the standards of that building. And if we look at the other standards and it's going to be very expensive, then this can help us to determine to stick with it or to look for other options. Now, in order to improve quality, we can use flowcharts. And in the PMBOK, there are two examples of flowcharts. One is called SIPOC. And SIPOC simply means supplier, input, process, output, and customer, right? Right. And why flowcharts are important is if you are working in a service-based environment, or you're into manufacturing and you want to know where the bottlenecks are or where issues are coming up, you can use flowcharts to identify where the issues are coming from or where the bottlenecks are. Another example of flowcharts that can be used are value stream mapping, and this can help us to see how much time and money is spent on each process in your system. And flowcharts are good when you want to improve the quality of service and you want to see where bottlenecks and other issues are coming from. Logical data model is a tool that helps us to see how data flows in the system. We can use this to identify areas where data vulnerability can exist or where data breaches, and this can help us improve data protection. And logical data model is more or less used in IT-based projects, software-related projects. Matrix diagrams helps us to show the strength of relationship between the factors of improving the quality of the product and also comparing them to products that are similar in nature. Then mind mapping is where we look at the relationship between quality requirements of a product. You can use a mind map to show the relationship of the quality requirements, based on a product. Last but not least, okay, we have test and inspection planning. This is where we start creating the test plans and how we're going to inspect the product. And finally, we're going to have meetings. At the end of the day, we create a quality management plan and quality metrics. These are the two main outputs. So that means most of what we're doing in the input tools and techniques are really focused on creating two major things, the quality management plan and quality metrics. Now, the quality management plan, like I said earlier, houses the quality standards. That means this is where quality standards are determined. It houses quality objectives, right? Which might be the defect rate and the roles and responsibilities, which talks about what people are going to be responsible for in terms of quality activities, who's going to carry out audit and inspections, and so on. Now, another output we see is quality metrics. Now, I want to explain the difference between quality metrics and quality standards. Now, quality metrics are the things we're going to measure. So take for example, you want to go for a health checkup. And when you get to the doctor, there are certain things they're going to test. They're going to test your BP, they'll test your temperature, they'll test your sugar level, all those things. Now, quality metrics are those things they're going to test. Blood sugar, BP, those are metrics. The standard is the ideal measurement that your quality metrics must attain. So let's say that I'm doing I'm going for health checkup. One of the metrics they're going to measure is my temperature, and if my temperature is good, it must fall between 36.3, 36.2, and 37.3 or 4. 37.3. If my temperature is between that range, then it means that I'm good to go, right? So that is the standard. So metrics determine what we measure. Standard determines the ideal unit that that product must attain based on the metric we're measuring. So that's the difference between quality standards and quality metrics. The quality standards are part of your quality management plan, or you could say the specifications are part of the quality management plan, while the quality metrics are the things we're going to measure. That's the two. So that's the key output for this process. Now, let's talk about difference between grade and quality. Now, grade deals with the characteristics of product, while quality deals with the stability and predictability of the product. So let's list two products, iPhone 10 and Nokia 3310. So there are two products. Now, when we talk about grade, we're talking about characteristics. And in terms of these two phones, iPhone 10 has a higher grade. Why? It has features that Nokia 3310 does not have. Nokia 3310 is an old phone. It's not even a smartphone. I'm not sure they built a smart version, but if it's the old Nokia 3310, it doesn't have as many features as iPhone 10. iPhone 10, being a smartphone, has a lot of apps, and you can do so many things. You can watch a movie, you can check your mail. Nokia 3310, you could call, you could send SMS, you could play the snake game that the snake keeps eating and eating. You have to avoid the snake eating itself. I don't know if you ever played that game, but it's also a feature in Nokia 3310. So when we're talking about grade, it's based on the characteristics of product, which iPhone 10 is more superior in terms of grade. But in terms of quality, it talks about how well the phone works. So here we're going to say they're both of high quality, which means even though Nokia 3310 is of a lower grade, it works so well. It works so well for what it was made for, right? So Nokia 3310 will be a lower grade but high quality. iPhone 10 is a higher grade and high quality. Quality talks about how well something works. And of course, if you buy something that is not of quality, one of the signs is that it does not last. So that's what we're talking about, how well it works. Let's talk about, so this is what you need to know about grade and quality. Low grade is low grade is acceptable, but low quality is not. Low quality is acceptable. That means that you can have a low grade, high quality product, but you cannot have a low quality, high grade product. What does a low quality, high grade product look like? It's probably a product that has so many features but doesn't work well. Like there was a time there were this what we call Chinko phones, Chinese phones that they were making at some point, and those phones had TVs, like they had small TVs in them. They had big touch lights. They were phones, but you could watch. They even had small antennas, right? But they didn't last long. So that's an example of having a high grade, low quality product. Phones that could do a lot of things, but they were not built to last. So according to PMI, low grade is acceptable, but low quality is not. Now let's talk about accuracy and precision. Quality ends up with testing your product because that's the only way we can ascertain whether your product is of good quality or not. And when we are testing, there are two concepts we need to be familiar with: accuracy and precision. Accuracy talks about the test results aligning with the target value. What does that mean? If a product is 17 kilograms and I'm using a scale to weigh it, and the scale is telling me 16.9 kilograms, it means the scale is not accurate. But when it comes to precision, if the product weighs 17 kilograms and the scale is giving me different results, then it's a precision probe. So each time I weigh it is giving me a different result. The first time I weighed is 16.9. The second time is 17.2 kilograms. The third time it was 17 kilograms. And each time you weigh it, it's giving you different results. That means that that instrument you're using has a precision problem. And that's that. Now, let's talk about prevention and inspection. Prevention and inspection. Prevention is the proactive side of quality, and this is where we put measures in place to prevent defects from happening in our project. These are your measures or countermeasures to ensure that defects do not occur. Inspection is the reactive side of quality that comes when we build the product and then we inspect and fix errors after the product has been built. Prevention is done in planning, and that's why we do quality planning to determine the standards that we need to meet and the measures we need to put in place to ensure that those standards are met. Inspection, on the other hand, is talking about fixing the errors we discover after the product has been built. So let's look at the cost of quality again. And remember, we talked about cost of quality being the cost of conformance and cost of non-conformance to quality. So let me explain the cost of conformance. If you look at the summary under money spent during the project to avoid failures, that's your cost of conformance. Let's look at some of the examples. And remember when I was talking about soil testing is part of your cost of conformance because you pay money to test the soil and to assess the quality of the soil to know the right. So when you're doing testing in a project, it's part of your cost of conformance. Or when you're training your staff so that they handle the work with better quality, that is going to cost you. It's going to cost you to train people or using the right equipment or documenting the processes. These are part of your cost of conformance and doing things at the right time. Now, if you don't pay for your cost of conformance, you're going to pay for it in the cost of non-conformance. And that includes internal. So cost of non-conformance is a cost we incur because we don't pay attention to the cost of conformance. And that leads to product failure. So there are two types of cost of non-conformance. One is internal failure cost. And this is where we find defective products in the project. And when you find defective products, maybe during inspection, there are two options. You either scrap it or we repair it. We scrap when the cost of repair is greater than building a new one. You can turn that product into a scrap. Now, if our eyes do not catch these defective products and it goes to the market and the customer finds that product, liabilities can come, which means the customer can sue, especially if there's a damage to the customer. Liabilities. Warranty work means that the customer returns the product under warranty and lost business. In terms of cost of non-conformance, lost business is, I think, one of the worst. What does lost business mean? Lost business means that the customer is so disappointed about the failure of the product that he never patronizes the business again. That means the business has lost a customer and they've lost the business. So imagine, and maybe maybe you remember a time where you went to a restaurant and their service was so poor that you vow never to go back. What does that mean? That restaurant has lost business and they can never get you back as a customer. Or you fly an airline and their service was so poor, you vowed in your life that you and your generation will not fly that airline again. Or you go to a hotel and you see rats and cockroaches in your room. What's going to happen? That hotel is not going to see you again. They've lost your business. And I think that's the worst of the cost of non-conformance. If if you pay for the cost of conformance and in that hotel they're training their staff on how to maintain cleanliness and hygiene, they will not get to the point where they're losing business. So it's either you pay for cost of conformance or you pay for cost of non-conformance. And that's what we. Let's talk about some quality terms like design of experiment and just in time. So when we talk about design of experiments, we're talking about a statistical process that are used to determine the factors that can influence variables associated with a process or product. And to give an example of this, I'm going to talk about the factors that influence the production of Coca-Cola and Fanta, production, soft drinks, if you like to call them, or soda, if you like to call it that. What are the factors that influence the process of producing? Number one, we have to look at the concentrate. And what is the concentration of the syrup that is being used? Now, what happens is that Coca-Cola, has franchises all over the world. They supply them with a concentration of the syrup, and then they ask them to produce based on the standards. Now, if the concentration of the syrup is changing, it could be a factor that can influence the quality of the beverage. Another factor that influences the quality of the beverage is the volume of CO2. Carbon dioxide is used as a preservative, and if it's not enough, it can actually cause the beverage not to last as long, or the taste to, the beverage to taste different. Have you ever drank Coke after the gas has escaped for maybe you left it in the fridge for 1 week? You see that the taste is different. That's because CO2 is no longer there. Another factor that influences the quality of your beverage is the temperature at production. When they are producing these beverages, they're usually produced at a low temperature because of the gas in the CO2 in the mixture. The CO2 is the preservative and it's mixed with the drink. So the temperature of production, if the production temperature is very high, means CO2 gas will be escaping from the mixture. And then another factor is the pH of water. So these are the factors that influence the variables associated with the production of soft drinks or soda. And for each of these factors, you can experiment with different units. So take, for example, let's say you're doing a design of experiment and you've pulled the concentration at a constant measurement. The volume of CO2 is constant. This is constant, rather. This is constant at a constant concentration, and the pH of water is constant. And then you're now experimenting on the different production temperatures, starting from 10 degrees, 11 degrees, 12 degrees, 13, 14, 15, 16, and 17. And you discover that the best production temperature is 15 degrees Celsius. Then this becomes a standard production temperature that is going to be used in all plants all over the world. Why? Because we've done a design of experiment. So what is design of experiment? It's simply through experimentation, we come up with the standards for producing the product. That's all it's saying. And it's a tool to determine quality standards for a product. You can experiment on the factors that influence the product. Now, just-in-time is an inventory management system where the inventory comes in time. It lets a company have little or no excess inventory in stock other than what they need to build existing inventory, existing orders rather. A company will stock zero inventory with supplies arriving only when needed for products being built. Now, what does this really mean? Just in time means that you do not overstock. You don't overstock spare parts, right, for building products. The parts come only when you have orders and you don't overstock, which means a company will have zero inventory once they finish building out their orders. What's the advantage of just in time? It helps you to save money. How does it help you to save money? Now, if you're not overstocking, right? Let me say it this way, if you're overstocking, that means you're ordering more inventory than you need. Then you're going to tie down money on the parts that you are not going to need to build now. Another reason why just-in-time is good is if you overstock, you may have to pay for warehousing space, which is an additional cost. So using just-in-time means that whenever you need products, right, they come only when you need it and you don't overstock. Let me give maybe a practical example. So you have a petrol station, right? And in that petrol station, they want to ensure they don't run out of fuel. So what they do is when petrol runs out, they get a tanker. The tanker fills the petrol station with fuel. And then it keeps an additional tanker in the petrol station so that when the fuel finishes in the petrol station, that additional tanker can just fill. But if you look at that scenario, you find out that number one, the additional tanker is tying down capital because we need extra money to get an additional tanker. That's number one. Number two, keeping a tanker in a petrol station for a couple of days means that we're not making money. We're just tying down money because the tanker is meant to be moving about to distribute products and you just tied one down. So instead of trying to overstock for a petrol station, why not try just in time? Which means when petrol is about to run out, you order your product so that it meets it just in time. That's what just in time means. It means you ensure that you time your supplies, that they come just at the nick of time, and then you fill your inventory and then plan it so that you get your inventory at, at the nick of time. That's just in time, and it helps you to save money. Now we're going to talk about the normal distribution and what it means in our project, normal distribution curve. And this is a distribution curve that shows um, what we expect from statistics taken from a population. Now, let me give an example. So let's say that you want to find out the height of men age 25 in a particular country. So let's say Benin Republic or Nigeria or in the US. And you want to find out the height of men age 25. Now, what you're going to notice is that there'll be an area of central tendency, which will be the mean height or the median height or the modal height, right? That's what this is, which means there'll be an average height of men age 25. Then you find out that there'll be outliers, right? So maybe this is one particular height, right? And as we go ahead, then maybe you can see extreme height at the right and left. So an extremely tall person, age 25, may have a height towards the right, and an extremely short person, age. So the frequency is going to be a bell-shaped, while the most popular or the average height or modal height or median height will be in the center. So that's what the normal distribution curve looks like. But why is it important? It's important because we're going to use the standard deviation, sigma. And sigma is given by pessimistic minus optimistic divided by 6. Now, sigma is standard deviation. And standard deviation is a particular figure that can be calculated using pessimistic minus optimistic divided by 6. But what is important, you don't need to calculate standard deviation. What is important in the PMP exam is the different values for standard deviation. For example, 1 sigma has an area of 68.26% of the entire population. What is 1 sigma? Is the distance between plus 1 sigma from the mean and minus 1 sigma from the mean. That's the distance. And the distance is 68.26%, which is covered by this. Is the area under that distance is 68.26% of the entire population. So that means that, if an organization is operating at 1 sigma, it simply means that 68.26% of everything they produce is defect-free. So take, for example, a company producing at 1 sigma. If they are producing 100 products, they need to ensure 69 products are defect-free. Why? Because if their quality standard is 1 sigma, of course, you can't get 68.26 products, so it has to be 60. So the moment 69 products out of 100 are okay, they've attained 1 sigma quality standard. But if a company is operating at 2 sigma, what does it mean? 2 sigma means that we extend, right, the area to where plus 2 and minus 2 exist. That means 2 sigma is this area, and 2 sigma is 95.46%. So, in other words, the sigma levels can represent the quality standards of production at your organization, right? And the highest level is 6 sigma, which is 99.9997%. So please don't forget 6 sigma is the highest, and that is the most accurate is 6 sigma. Now let's look at a couple of them so that we see how different they are. So of course, 68.26%, that's 1 sigma. 2 sigma is 95.46%. 3 sigma is 99.73%. And 6 sigma is 99.9997%. Now, my question is 3 sigma much different from 6 sigma? Because if you look at 3 sigma, it is 99.73%. Right? And 6 sigma is 99.9997%. So is there any difference between 3 sigma and 6 sigma? Well, it might not look as if there's a difference, but if we remove the decimal point, we might actually see there's a difference or not. And how do we do that? When you remove decimal points, you add more zeros. So 99.73, if you want to remove the decimal points, we're going to add 2 zeros below. That becomes, that can be rewritten as out of 10,000 products, 9,973 products should be defect-free. Yeah. 9,973. That means that out of 10,000 products, only 27 products can be defective. But let's look at 6 sigma. What 6 sigma is really telling us? 6 sigma is saying 99.9997 over 100. And that is, if we want to remove the decimal points, we have to go 4 places, and that will mean 1 million. So that means that in 6 sigma, if we remove the decimal point, what's going to happen is we are saying that out of 1 million products, 999,997 items should be defect-free. So that means that what 6 sigma is saying is that we have 3 or less defects per million, as against 3 sigma, which is still looking at defects on the scale of tens of thousands. 6 sigma is looking at defects on the scale of 1 million defective products. So that's what we are saying here. Okay, that's what we are saying here. We're looking at the level of precision, and that means if you're going with 6 sigma, it means your results will be more precise than other levels. Okay, so that's what you are concerned with at the sigma levels. If they say you're operating at 3 sigma, just know that they're talking about 99.73% in terms of the proportion of the population that are under 3 sigma. Okay, so that's how we use this concept. Now let's move on and talk about 6 sigma, and it was Motorola and other companies that made 6 sigma popular in the late 1980s. And it involves setting very high standards of Six Sigma for products or processes that the company produces in essence. This philosophy states that approximately 99.9997% of everything the company creates or the processes it executes are error-free. So let's talk about the ISO 9001:2015. This is a quality management system that an organization can use to improve their processes. And of course, is certified by ISO. And ISO comes down to 3 steps. Document what you do what you document, and document any variance from normal process. Document what you do what you document, and document. That means if an organization is going for ISO 9001:2015 as their quality management system, you have to ensure that you have your standard operating procedures and you follow them and you have variance. So companies that apply for ISO 9001:2015, one of the reasons they do this is to show that they are a standardized organization. And the advantage of having an ISO certification is that it gives foreign partners the confidence to work with the organization, showing that it's following standard operating procedures. So let's talk about who's responsible for quality. The team member or worker is responsible for the quality of their work. The project manager's job is responsible for setting the quality standards on the project, and senior executive and management is responsible for setting the quality standards at the company. Okay. So let's look at some quality tools and let's look at flowcharts. You've talked about flowcharts earlier, and I mentioned that they can come in the form of SIPOC, which is supplier input process output customer. Now, one of the advantages of using flowchart as a tool in quality planning is that it can help us to map out the flow of processes, and flowcharting helps to increase the stability and predictability of a process. So we can use flowcharts to ensure consistency in our processes and so on. So let's talk about another tool, fishbone diagram. Fishbone diagram has three other names or 4 other names. Fishbone diagram is first of all known as fishbone diagram. It's also known as Ishikawa diagram. Ishikawa diagram is also known as cause and effect diagram. So how does this tool work? The fishbone diagram shows you things that can cause potential effects. So the head of the fish is what we're anticipating can lead to defects. So what can lead to software defects? In the requirement phase, we can get software defects. While integrating, we can get software defects. During designing, we can get software defects. And during testing. So when you're using a fishbone diagram as a root cause analysis tool, what do? So we try to look at where the software defects can come from. So, for example, is there a scope change? If there's a scope change, then it can lead to software defects. If while gathering requirements, we don't get all the requirements are incomplete, they are incomplete, then the customer will say that the software doesn't meet all stakeholder requirements. And then, so we can use a fishbone diagram, and it's also known as a root cause analysis tool. So if you look at all the areas of project, the team will brainstorm and look at things that could potentially cause defects using the fishbone diagram. Okay. So let's talk about the next process, which is called manage quality. And this is the process of converting quality management procedures into actionable quality activities that incorporates the company's quality policies into the project. The advantage, and of course, this helps us to discover inefficient processes, causes of low quality, and it helps to reflect the overall quality state of the project to the stakeholders using data and results from the control quality process. So let's look at manage quality. So when it comes to manage quality, I need us to understand something. Manage quality is where quality assurance is done. And I need to explain the difference between quality assurance and quality control so that we can appreciate this process. Now, what's the job of quality assurance? Let's look at any product or anything you want to create as as the kind of process it goes through. So let's say we use a raw input or material, and then we take the material and process it. Say process one, take that and add process two, take that and add process three, and take that and make it a product. So let me put things so that we can see. So first of all, let's say the raw input is raw meat. And the first process is to put on sticks. That's the first process. The second process is to season. The third process is to barbecue. And the product is suya or roasted meat. Right. Now, the job of quality assurance is to validate your processes, while the job of quality control is to validate the product itself. So managed quality is more concerned with validating the processes, which is the this side of the equation. That is quality assurance. Because if the processes are done correctly, it should assure us that the final product will come out well. Right. So quality assurance validates the process. So what do we mean by validating? This is why auditing is usually a tool used in quality assurance. And auditing enables us to audit that the process was done according to the process standards. Right? Take, for example, let's say there's a particular measurement of salt, pepper, and other ingredients, and there's nobody to audit that this mixture was according to the standards. And what's going to happen is that there's going to be a problem with seasoning because it's going to start affecting the taste of the product, right? In terms of suya, if there's no one to audit the seasoning process. So quality assurance validates that processes are done according to plan. And then quality control, which is called QC, quality control, sorry, is done when you test the final product. Okay. Okay. QC, quality control, is where you test the final product against specification. All right. Where we test the final product. Okay, so that is, so quality assurance validates the process. Quality control is where we test the final product to see whether it meets up with the quality standards. And that's what we are saying here. That's what we are saying here. Okay. Right. That's what we are saying. So so quality assurance is focused on the processes meeting up with the process standards or metrics. Now, so in managed quality, quality assurance is one of the things we've talked about. Another thing is process improvement and quality, managed quality also includes product design. So quality assurance validates the processes. This process also makes room for process improvement, and we also look at product design. So let's look at the input here. Let's look at the input. Now, the quality management plan is where we have the quality standards for the project. Then lessons learned from past project areas. Quality control measurement is the output of quality control. Then we have the quality metrics, risk, and organization process assets. That means that in managing quality, your quality standards are there, quality metrics are there, and the result of quality control tests. Now, in order to manage quality, we need a number of tools and techniques. So number one is that we can use a checklist to ensure that all the processes are done as planned. We can look at alternative ways of improving our processes. We can do process analysis to find where root cause of poor performance, right? We can also use decision-making techniques to look at multi-criteria decision analysis. And here, what we're saying is that look at other factors that influence the output of your processes. Data representation, we can represent data using affinity diagrams and cause and effect diagrams. This will show the cause and effect diagram is Ishikawa diagram. Right. You can also use flowcharts, histograms, matrix, scatter diagrams, and audit. And that's what we're saying here. Now, design for X is where we design for certain attributes. Design for X means design for certain attributes. So what does design for X mean? It means that we're focusing our design on a particular attribute. That's what design for X means. So take, for example, let's say Samsung wants to get more customers for a particular product. They can decide to use design for X. How does it work? So design for X could mean X is anything. You know, when you put X in a formula, X can mean anything. So design for X could be anything the product is meant to focus on. So take, for example, our design is for affordability. We want to make our products more affordable. That means we're going to look at product guideline on how to achieve affordability. Take, for example, Samsung. If you are buying the premium Samsung phone, right? One thing you notice is that in Samsung phone, the casing is metallic. It is metallic, right? But Samsung has some phones that are not metallic, they're plastic, so that they can make cheaper versions. And that's what Design for X for. So when we talk about Design for X, it means we create design guidelines in line with a particular attribute we want, whether the product should be cheaper or something else. It goes with the Design for X. So we can use problem-solving techniques and we can use quality improvement methods. So quality improvement methods like Plan, Do, Check, Act and Six Sigma can be used to start a project on how to improve quality in a system. So at the end of the day, what we have is quality report. And quality report is the report on the quality of the outputs of the project and can recommend ways of improving quality. Test and evaluation documents are created, and this helps us to do the final product test and evaluation. And these are the two major outputs. The quality report, which tells us what's going on in the project, and then test and evaluation documents, which are used to test the final product. So managed quality is largely where we focus on ensuring that our processes are done correctly. Is where we do quality assurance. Okay. So let's continue and talk about the last process, which is control cost. So what is control cost? Control quality level. Now, this is the process. This is the process of comparing a product's or a process output to specifications. And this is the thing, this is where things roll off the line and they'll be measured against approved standards in control quality. And that is, now to summarize, what control quality is saying is that the final product is tested against specification. And that's exactly what we're doing. Let me go to the tools and techniques. So this is where product testing, this is where quality control is done. And quality control is simply testing your product against specification. You can use a checklist to do this. You can use a check sheet to collate the number of defective products. We can do statistical sampling, and statistical sampling is divided into two, population and sample testing. And sample testing. So what does this population testing mean? If you're population testing means that you test every product you create. Sample testing means that you don't need to test every product you create, but you must have a sample test. Now, there are some products that by nature we have to test everyone created, like airplanes. You can't afford to do sample tests. And in sample testing, there are some guidelines towards sample testing. For example, if your testing is destructive, then you can't do population testing. What do I mean, destructive testing? If you have to destroy the product testing, like phones, you can actually use a hammer to crack the screen to see how strong the screen is. That's called a destructive test. And phone manufacturers do it, right? So if you are doing destructive testing, You can't do population testing because it means you're going to destroy everything you've created. So when it comes to sample testing, we can say that sample testing is going to be done when we have when we're doing destructive testing or when testing is too costly and we don't want the product to be too costly. Questionnaires and surveys after the product has been delivered to customer. The questionnaires and surveys can um, can be done to get feedback. Then we can also do performance reviews of the product, look at the root cause analysis. We can also inspect the final product. Root cause analysis is where we try and determine the cause of failure. And then testing and product evaluation is done here because we've gotten to the point where we created a product and we are testing against specification. Then we can use some tools like cause and effect diagram, that's your Ishikawa diagram, control chart, histogram, and scatter diagram to learn from the results of our test in the project. And we can also create quality control measurements and verified deliverables. What are verified deliverables? Verified deliverables are products. You can see in the input, they are just called deliverables. But when they pass quality control, they are called verified deliverables. So the main output of control quality is the quality control measurements and the verified deliverables. Verified deliverables are the products that are past quality control. Well, let's look at this before we move on. Do you notice that in managed quality control measurement is an input, but in control quality, quality control measurement is an output. So what does that mean? What does that mean? It means that the question we should ask is which one is done first? Is it managed quality or quality assurance? Or is it quality control? Quality assurance is done in managed quality, and it means that the quality assurance is done before quality control. So the question is, if quality control is what gives us the quality control measurement as an output, then how come it's an input in managed quality? Which means if managed quality is done before quality control, how can quality control measurement be an input? And to solve this mystery, we have to go to the beginning. Because if you don't understand what is going on, you might miss things out. So let's look at the entire process again before we start wrapping it up. So where do we start from? Now, if you look at the definition of quality, quality is the degree to which a set of inner characteristics meet requirements. Question is, where did we get requirements? We got requirements from the collect requirement process in scope management, which means once you've drafted the requirement, you can start quality planning. So based on the quality planning, we will now determine the standard we need to meet up with customers' requirement. That's one of the things that quality planning does. It helps us to capture the standard that will help us meet the requirements. Now, we now pass through managed quality, and this is where quality assurance is done, and we ensure that things are done according to plan, right? And processes meet up with their standards. And we audit processes in managed quality. Then finally, we do quality control. That's where we test the final product. And the result is quality control measurement. And what about measurement? It's an output of control quality. And this is where we test the final product, the result of quality control measurements. Now, let's say that the project is to build 100,000 laptops that we use for the next elections. And of course, elections are a very sensitive topic. And this time around, they want to get equipment that can collect data very well. So they are going to have their own requirements. So in building this 100,000 laptops, we're going to collect requirements. And after collecting the requirements, we're going to create standards. So for example, while collecting requirements, this 100,000 laptops, what must it have? Someone said it should have 17 hours battery life. Another person says it should have biometric signature. Another person says it should be small, it should be 70. Now, when you're collecting requirements, you start creating standards because they're specifying what they want, and we can create standards. So we know that it's going to be a 7-inch laptop. It's going to have biometric sign-in. Is based on the requirements, we determine the quality standards. Now, let's say that our company can only produce 10,000 laptops per batch. So what's going to happen is that the first 10,000 is going to be produced. While we're producing the first 1,000, we're going to do quality assurance, ensure that processes to build the laptops are audited. We're inspecting what they're doing, and then they build the first 10,000. And then we're testing the laptops, and we found out that 50 of them had screen issues, 20 of them had biometric issues, 100 of them had video issues, and so on. And that is the quality control measurement that goes back. And when we're building the next set of 10,000, we're going to use the result of quality control measurements from the last batch of production, QCM, to improve the next batch. That means we're getting feedback. So if 50 laptops did not have biometric, when we're building the next 10,000, we're going to look for process improvement that can solve that problem. And then we implement it when we're building the next 10,000. When we do quality control measurements, the results should show better performance. And that means that quality assurance, right? When you do quality assurance, it leads us to, quality control, which means if quality assurance is done well, we won't have quality control issues. But in the same way, when we get the results of quality control tests, which is when we test the final product, quality control measurements serve as a feedback for us to adjust our processes to improve the product. And if we keep producing 10,000 laptops and we're getting feedback based on what we produce, then if we continue producing, getting feedback, improving our processes, getting feedback, improving, then we're going to get what we call continuous improvement, which is Kaizen, which means that every time we produce 10,000 laptops, we have an opportunity to improve something in the product, and that continuous feedback, right, can help us improve the product. So that's what's going on in quality planning. We start by determining quality standards, quality metrics. We come to manage quality and ensure that we have quality assurance systems in place to audit the processes that are being executed. And then finally, doing quality control and get the quality control measurements, which will be used to evaluate the performance of the last set of products and help us determine how to improve quality. And that's what we're saying. So this picture actually talks volumes. It actually involves Kaizen, which is what we are talking about. So let's wrap up on this knowledge area and call it a day. And in wrapping up, we want to look at a few more tools. And let's talk about Pareto diagram. So Pareto diagram is a cumulative histogram. What does that mean? It's a histogram that uses Pareto principle. And what is Pareto principle? It's called the 80-20 rule. And Pareto discovered something in his country. He discovered that 80% of the wealth of his country was controlled by 20% of the citizens. And from that, we've drawn a conclusion to Pareto principle that 20% will cause 80%, will influence 80%. And you can use it to prioritize. For example, you could say 20% of your staff are doing 80% of the work, or 20% of your clients are bringing 80% of the revenue. And we can look at it this way. So when we talk about the Pareto diagram, it's used when we want to determine where most of our failures are coming from. Let's look at this example using a Pareto diagram. And in order to see, I'm going to zoom in. So let me zoom in. So we have here a company like Hewlett Packard, who has produced printers. They produce thousands of printers. But when we are testing, we get this result. 8 printers do not have toner ink in them. 7 printers have paper jam issues. 6 printers have cable broken in them. 5 printers have driver issues, and 4 printers have other issues. Now, to create a Pareto diagram, what you do is you add up the frequencies. Sorry, okay, let me move the way. You add up the frequencies, and so the first is 8. The next one is going to be 7. 7 plus 8, 15. 15 plus 6. Next one. Yeah. And the next one, 21 plus 5, that's going to be 26, and so on. So to use the Pareto diagram, you add up the height of the issues, and in this case, they represent 30 items. Then you divide this into 100 equal parts. When you have the 20%, you draw a line. The issues that go above 20% are the issues causing 90% of the problem. So any issue that goes above the 20% line also going. So what does that mean? It means if I want to solve the printer problems, if I can solve these 3 that go above the 20%, these 3 are the issues causing 80% of our manufacturing problems. So using Pareto diagram, I can pinpoint the most effective way of solving defects. Because if I can solve these 3, they represent 80% of all the problems we're having in this product. The Pareto diagram can help you to prioritize on which defects you need to solve. Now, when you're doing product testing, you can use a scatter diagram to see if there's a correlation between products, things that you're testing. So let's say to determine the quality of the product, you need to test the weight and the density. And if you want to know whether, so there's a particular weight and density that item must have. If it doesn't have, then maybe it's defective. So the scatter diagram is where you want to see if there's a relationship between two variables you're testing, maybe weight and density. And so you look at all your samples and plot a diagram, right? And if you can draw a line of best fit with the data points close to the line of best fit, it means there's a relationship between the two variables that are being tested in your project. Let's talk about the last tool, which is called the run chart. The run chart is a picture of the outputs of your product over time. So imagine there's a conveyor belt, and these are the products that have come out. And you want to determine, right, you want to determine whether your products, how well your production is going. So let me explain the mean, upper control limits, lower control limits. So the mean is the target, let's say weight. Let's use weight now. Or so let's say that you are meant to produce FIFA balls for FIFA. And of course, FIFA will have some strict requirements on their balls. And let's say that each ball must weigh at least 3 kilograms. Now, of course, we know there's variation in nature, which means it can weigh between 3.1 kilogram and 3.2 kilogram. 3.2 kilogram. All right. Or it could, oh, sorry, this should be 2.9, 3.1. Or it can weigh even more, which is 3.2 kilograms. And this could be 2.8. Now, how do you read a run chart? Now, all these are, but all these points are measurements of a product that has been produced by the company. And what you notice is that some products are outside the control limit, like this. This one's outside the control limit. And some products are out of control. The goal is to ensure your products are within the control limit. But there's another place we need to look at, which is this point. And what is this called? It's called the violation of the run 7 rule. So what does that mean? When you have 7 consecutive data points above or below the mean, you need to investigate. So what do I mean by that? Look at this. 1, 2, 3 are below the mean, and it switches to the other side. 1, 2, 3 are above the mean, then 1, 2 are below, then 1, 2, 3, 4, 5, 6, 7 are above. Now, what is the violation of the run of 7? Now, if you look at this very well, you notice that these products are within the control limits, which means these 7 products are okay. But because of the consistency, it might be an indication that one of your machines is about to give up. So it's giving you signs already. It's not random anymore. It's tending to a certain level. So if you are using a run chart, when you find some consecutive data points above or below, you should investigate the system to see if there's going to be any failure happening soon. And that's it. So when we have investigated, we look for points that are out of control, out of specification, and violation of the run of 7. So what happens is, when we have found any of those points, we look for an assignable cause. And assignable causes could be special causes or common causes. Special causes are unusual events that happen that we don't expect to see. Common causes are sometimes called normal variation, normal process variation, or random causes. Now, going back to the chart, this is how we interpret it. So for products that go out of control, right, we call them common causes. Why? Because from time to time, process variation can make the product go out of control. But products that are outside the specification limit are called special causes. And in order to improve quality, what you have to do is reduce the number of common causes after investigation and eliminate the number of special causes, and you should improve quality. And this is all we have for quality chapter, and of course, our time as well. So on Thursday, I'll finish cost management, and then we'll switch to quality management, communication management. The reason why I didn't take cost is because cost has some technical areas that I think we need to do together. So on Thursday, we'll continue with cost management. All right. Thank you for your time. See you tomorrow. Bye.